Now let's see how to convert binary to gray. So why should we convert is, it is very easy to write a number in binary rather than writing it in gray directly. If you have to write a number in gray, you have to use this method, which is going to take a lot of time. Now let's write a number in binary and then convert it to gray, and later we shall take a gray and convert it to binary. We shall do both of them. Now let's see this. We know that I have just taken one example, right? Earlier, yes, 12. So binary 12 is 1 1 0 0. So this is 12 in binary. Now I want to convert it into gray. So we know that gray here is 1 0 1 0, right? So you just copy this bit as it is, okay, and then take these two bits. See, MSB is being copied as it is, and take these two bits and you find out the exclusive OR. Then what do we get? 1 and 1 is exclusive OR. If I do it, it is going to be 0, right? And you take these two and you find exclusive OR, and what is it? 1 exclusive OR 0 is 1. You got 1. You take these two, find out exclusive OR. 0 exclusive OR 0 is 0. So 1 0 1 0 is representing 12 in gray. Got it? So therefore, if this is binary 12, the gray is 1010, right? So how did we get this? How to write it in terms of a formula, and how to design a circuit which will convert the gray code to binary? Because ultimately we want the numbers in binary, right? So how to convert the, how to design a circuit? For that you have to know what are the gates you are supposed to use. So if the binary number is, let's say it is represented like this: B4, B3, B2, B1. This is B4, B3, B2, B1, and if the gray is G4, G3, G2, G1, if this is the gray code, then how did we get this? So it is simple. Now G4 is equal to B4, right? And G3 is equal to B4 exclusive OR B3, right? And G2 is equal to B3 exclusive OR B2, isn't it? And G1 is equal to B2 exclusive OR B1. Therefore, we need exclusive OR gates to get the output. So you can design a circuit like this. How many exclusive OR gates we need? 3 exclusive OR gates. So 1 for 4-bit number, 2, 3 exclusive OR gates you can have, and directly B4 is going to be output, right? So if you have here one is B4, B3, and then B2, B1, right? Let's connect them appropriately. Now G4 is going to be from B4. Now look at G3. G3 is from B4 and B3, right? Which means these two have to be given to this. And now you are going to get G3. And what about G2? B3 and B2. So which means B3 and B2. You are going to get G3, G2, right? And what about G1? B2 and B1, which means this one and this one. You are going to get this one. Understood this? Okay, so if you have 4-bit numbers, converting this using this method, you might feel that this method is easy and you want to go with that. Let's do one more. Okay, for just the sake of practice, let's do one more example, and then I'll take a bigger number and I'll convert it. So let's say I have 15. So binary 15. So in binary 15 is 1 1 1 1. And in gray 15 is 1 0 0 0. Now I want to convert this binary to gray. How do we do that? Write this most significant bit as it is, and then take the exclusive OR of these two and get the next bit. So what is it? 1 exclusive OR 1 is 0, and take the exclusive OR of these two and write it. So what is it? 0. Exclusive OR of these two, what is it? 0. Got it? So this is the gray. Now writing this is easy. 4 bits is easy. Let's take a bigger number. Let's say I want to convert number like 200 into gray. So let's write the binary representation for 200. So what is binary representation for 200? 200 is 200, 100, 50, 25. 25 is 24, and then 12. Yes, from 12 we can go to 200. So 1100 is 12, and then if I put a 1 it is 25, if I put a 0 it is 50, if I put a 0 it is 100, if I put a 0 it is 200. Okay, so it is 200. Now I want to convert this 200 into gray. So how can I convert it? Take the MSB, write it as it is, and then you take the exclusive of these two and you find it. So exclusive of these two is 0, and you take the exclusive of these two, and what is it? 1. Take the exclusive of these two, what is it? 0. Take the exclusive of these two, what is it? 1. Take the exclusive of these two, what is it? 1. Take the exclusive of these two, what is it? 0. Take the exclusive of these two, what is it? 0. Therefore, this is the number which represents 200 in gray. This is the number which represents 200 in binary. This is the number which represents 200 in gray. Now let's try to do the other way. So what is the other way? Given a binary gray number, gray code, I want to convert it to binary. Okay. So let's see the other way. Now I am assuming that we are given a gray code and I want to convert it to binary. So why can't we do it directly? Because doing it directly is really a very big task, right? Because you have to write all the combinations, and then in those combinations you have to search for what is given. That is going to be really hectic. So let's do it in a simple manner. So the simple manner is this here. Watch it. Let's take the gray of this 12. So gray 12 is 1 0 1 0, right? I want to convert it to binary. So again the rules are simple. So write it as it is, the MSB as it is, and now you take this one and you find out the exclusive OR and you find the result. Write the result here. 1 and 0. Exclusive OR of 1 and 0 is 1. Therefore write it here, right? And you take this one and you find out the exclusive OR. It is 0. And you take this one and you find out the exclusive OR, which is 0, right? Therefore we got 12 again, right? So if this is the 12 in gray code, this is the 12 in binary 1100. You know that already. Now how did we get this? So what is the formula and how to design this circuit is, if this is the gray code, it is, let us say it is G4, G3, G2, G1. I am representing the bits of gray using G1 to G4. And if this is the binary, B4, B3, B2, B1. Now how are we going to represent it? Check this. So we have directly written whatever is G4 as B4. Therefore B4 is equal to G4, right? And next thing is, I want to find out what is B3. So B3 is nothing but B4 exclusive OR with G3, isn't it? Therefore it is B4 exclusive OR with G3. But then it is better if you write the output in terms of input. Output is binary number, input is gray code. I don't want to write the output in terms of again this output. So B4, I want to replace B4 with this. If you see this, we know that already B4 is nothing but G4. Therefore I am writing it as G4 exclusive OR G3. The reason why I am doing this is simple. I want to write the output in terms of only input, so that when I design the circuit it will be easy for me. Okay. And now what about B3, B2? Check B2. So B2 is obtained by taking B3 exclusive OR G2, right? Therefore B3 exclusive OR G2, B3 exclusive OR G2 is B2. And now how do we get B3 then? So check this. B3 is nothing but G4 exclusive OR G3. Therefore in place of B3 I am going to write G4 exclusive OR G3. So G4 exclusive OR G3 exclusive OR G2. This is B2. And what about B1? Check this. B1 is B2 exclusive OR G1. B2 exclusive OR G1, right? Now what is B2? B2 is all this, which is nothing but G4 where is it? Exclusive OR G3 exclusive OR G2 exclusive OR G1. Got it? So now we can design a circuit using all this. So how many exclusive OR gates we need? So So we have to take them in terms of steps. So I am not going to design it, you please design it. It is nothing but one is 2 input exclusive OR, other is 3 input exclusive OR, other is 4 input exclusive OR gate. You can design that. Okay, I'm not going to do that. So let's see how to convert it with some more examples. So one example is, so we have already taken one more example here, I guess, yes, 15. So 1000 is 15 in gray, and when we convert it to binary, we are supposed to get 1111. Let's see if this method works or not. So 1000 is 15 in gray. Let's convert it to binary. So write it as it is 1, and then you take these two and you apply exclusive OR. Then what do we get? 1 here. Are you getting this? You take these two and you apply exclusive OR, we got 1. And again we take these two and you apply exclusive OR, we got 1. Again you take these two and you apply exclusive OR, we got 1. So this is how we convert this this gray to binary. So this is 15 in gray and this is 15 in binary. You know already this, isn't it? Let's say how to convert this 200. If this big number is given, 200 is given, and you want to convert it to binary, let's see how to do that. So the number given is 1 0 1 0 1 1 0 0. I want to convert it to binary. Now take the exclusive OR of these two. So what is it? 1. Now take the exclusive OR of these two. What is it? 0. Take the exclusive OR of these two. What is it? 0. Take the exclusive OR of these two. What is it? 1. Right? And now take the exclusive OR of these two. What is it? 0. Take the exclusive OR of these two. What is it? 0. Exclusive OR of these two. What is it? 0. Now check that. So given number is 1100 1000. So number we got is 1100 1000. Got it? So this is 200 in gray, and which we converted to 200 in binary. So this is how you can convert from gray to binary and binary to gray. So what are the questions they might ask is, they might give you a number in one of these number systems and they will ask you to convert it to the other code. You can do that. And the second one is, they will ask you while converting if this is a representation. Sometimes the representation might vary. They might use B0 here, B1 here, B2 here, B3 here. So you have to be careful with that. In general, what type of questions they will ask is, in converting from binary to gray to binary, they will say that we have GN. Now what is GN? If it is not the most significant bit, what is G? How do you get the GN from binary? Then you have to check this. So what is it? BN plus 1 here, right? Exclusive OR BN. This is the general formula, right? In case if n is not the most significant bit. In case if n is the most significant bit, then Bn plus 1, Bn equal to directly Bn, Gn equal to Bn. In case if it is not the most significant bit, if n is not the most significant position, then Gn equal to Bn plus 1 exclusive OR Bn. So you need not by heart this formula, you just remember this this method. From this you can derive it, right? Similarly here also they will ask you what is the formula in a n bit conversion, what is the formula for B1, right? Something like this. If they ask you for the formula for B1, it is nothing but Gn to G1 exclusive OR of all this, isn't it? So it is Gn exclusive OR Gn minus 1 exclusive OR, so on, exclusive OR G1, right? So if you know this, you can directly answer it. Okay, fine.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So, first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%. But all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177 and IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.